All right, g'day San Jose. We're going to change tact a little bit here and going to look at the work stream that I manage, an update on that, and that's hardware management for liquid cooling. So this presentation consists of two parts. The first part is an update on the work stream, hardware management for liquid cooling. The second part is an example of how this could be applied to solve a real-world cold plate problem. My name's Mick Jones. I'm an architect for Vertiv, and hopefully in the audience somewhere, John Leong from Intel is popped in. Now he helped contribute to the second part about the cold plate abstract, so I'm hoping he will pop in and be available for questions. He's more of the redfish expert, so if there is any questions about that part, I will be able to hopefully refer to him. Okay, so what is hardware management for liquid cooling? It's something that kicked off in April this year. It crosses across all 5 of the projects, and what we're looking at is creation of a common schema and profiles on top of that to manage all the hardware for liquid cooling. Okay, so part of this is an interface with the DMTF Redfish DSIM task force. So we're working with them to make sure we capture all the requirements for managing liquid cooling hardware. The other aspect we're doing is harmonizing any current requirements. The immersion community already had some requirements in their documents, so we're synchronizing those with the work we're doing across the other projects. And the end goal would be a release of Redfish that includes schema that encompasses all hardware management for liquid cooling. Okay, so this diagram just gives you an idea of what we're trying to provide schema and schema resources and connections for across all the liquid cooling. So like I said, it covers resources across ACF, heat reuse, cold plate, immersion cooling, and rear door heat exchangers, plus any other ancillary or sensors, controllers, etc. that we come across during the meetings. Okay, so this is a pretty heavy slide, so I'll just give a summary of this. This is our progress so far. So we've captured common properties for all the device types. We've looked at the high level, which I just shown. We've looked at door heat exchangers, cold plate, ACF heat reuse, CDUs. We've done a mock-up of a CDU, which unfortunately I won't have time to show that today. We've done immersion cooling, so we've captured the attributes, the connections, the schema for all those different types of resources and their interconnectivity. We are currently looking at events and alarming. That's in progress right now, so that would be message registries, event models. How do you subscribe to events? What alarms will come out of the equipment? In the future, we'll be creating profiles, and a profile is kind of a confirmation that the server, the hardware management implementation that you have done conforms to the OCP requirements. So you would run a profile validation on that, and it will tell you if you meet the profile or not. So we'll be doing those probably for each equipment type. A door heat exchanger one does exist, so we'll be doing ones for CDU, for immersion, etc. And then last but not least, we'll be looking at security of these hardware management solutions. Okay. Excuse me. A couple of other community items that we looked at. We looked at normalized telemetry for real-time normalized telemetry that you can then access upstream for things like analytics, decision-making, control loops, and I'll look at that in a bit more detail when I get to the example. We looked at should we be providing support for the, want of a better word, legacy protocol. So should we have support for Modbus, SNMP, BACnet? And the community decision on that was it's relatively easy to create a transformation to help you to spit out the registers or the SNMP MIB. So we won't We won't be covering that in the work stream, but someone could create a transformation to ease in the creation of those. In terms of aggregators, which I'll talk about soon, we kind of, as a community, said that any southbound interfaces should support redfish. Okay, I'll come back to the current work items, but there is a work in progress release that was released last Friday by the DMTF. When it gets called to action, I'll bring that up again. And we also have a work in progress spreadsheet where we capture what's going on and how it, where it is in the process of becoming part of the schema in redfish. Okay, so this is an example of the schema resources and the interconnectivity that we've gone through. This is a door heat exchanger. You can see that in the middle left there. And then off that, you can see things like controls, the fans for a door heat exchanger, sensors, links to the upstream, like the facility that it might belong to, some metrics, so environmental metrics, some thermal metrics that will give you summary about the performance of that device. Okay, so now I'm going to look at a specific application of hardware management for liquid cooling. And this is to do with the cold plate problem. And the problem at its heart is that when you have a CDU, for example, providing fluid to all these cold plates, the CDU has no way of knowing what the performance is at the cold plate level. So what we are proposing here, and I'll get to the diagram in a second, is that using a redfish aggregator and using the schema modifications and the attributes that we are coming up with in this work stream, we'll have a method that the aggregator can generate a metric report that the CDU can consume, and the CDU controller will know what's going on at the target, at the cold plate level. Okay, so that, again, this diagram might be a bit difficult for you to see, but in the middle you've got the manifold distributing the fluid out to the servers, and each server is going to have a BMC, right? And in this example, you can see on the right, the BMCs have a redfish link up to the redfish aggregator, and on the left, you have the CDU controller. And what's happening here is at the redfish service, we're aggregating all those southbound BMCs, and we can provide what's called a metric report. And that can be done on a subscription basis, so however often you need it, like every 10 seconds, it can send a metric report to the CDU that says, here's all the BMC temperatures or power consumption or whatever it might be that you want to use in the control loop. And the CDU can look at it and say, hey, server 2 is getting a bit too hot, maybe I need to increase the flow rate to make sure it stays within parameters. Okay. So before I go on to the example of the metric report, this problem also occurs in what we're calling the enclosed chassis immersion. So where the whole chassis is filled or flooded, and again, this problem occurs where you need to aggregate all the chassis controllers or the BMCs. They need to be aggregated up to the CDU. So again, it can have visibility into the performance of the system and potentially use it as a control loop. Okay, so this here is just an example of a metric report. So basically, like I said, we're aggregating readings in Celsius from the BMCs, and that's provided to the CDU, and we can go, hey, this one here is trending up. Does the CDU controller need to do anything about the flow rate? And just as a quick link, if anyone was paying attention during one of the previous speeches, we were talking about leak detection in the BMCs, and that has also maybe a future applicability here, in that if the CDU is getting a leak detection aggregation warning, it may be able to, in the future, control the manifold and shut down that specific outlet, thus avoiding turning it into a flooded chassis, which in this case it should not be. Okay. All right. So this diagram here is just reiterating what I mentioned before about the control flow. So on the left in the light yellow, you have the BMCs in aggregate, and then that is aggregated by the Redfish aggregator, which you can then generate the metric values as a metric report, which can be sent to the CDU, and its controller logic can optionally send a command to the flow rate control, like I said, which can potentially increase the flow and prevent the server that's running at a high load from throttling or even potentially shutting down to avoid damage. Okay, so in conclusion, like I said, the effective cold plate optimization, it requires that feedback loop. It requires integrating the telemetry from the BMCs in the rack, potentially across multiple racks if it's a CDU that services multiple racks. In terms of this, it may be more applicable to single phase because the loop diode temperature can be affected by the flow rate. For two phase, you may be using a different control method because from my understanding, if you just pump in more fluid, it doesn't necessarily mean that it'll be the optimum for two phase because it might not have time to evaporate. But you still get a benefit from this solution because you have visibility into what the cooling performance is, because you've got the metrics coming back. You can see patterns in that are occurring. Okay, so obligatory call to action. Like I said earlier, I run the work stream. It's on the first and second Wednesday of every month at 8 o'clock Pacific, and it applies to anyone needing to manage liquid cooling environment within the OCP. So if you need to find out what the latest status is, I've got the link there. And the most important thing here is, like I said, there's a work in progress white paper that was published. That's what the QR code goes to. So we really appreciate if people can go in, read through that, give comments, so we can get to an initial release of this, and we can all start using Redfish to manage our thermal environments. Okay, so I've got good time for questions, exactly. So is there any questions? Yep.
So it seems the BMC is going to be part of this ecosystem then.
Yes.
So will this schema go in and give some specifications and requirements on the folks that are doing the firmware for the BMC as well, what we expect to see and availability? Or do you believe that's natively there and not an issue?
So from a BMC perspective, if it supports Redfish, it's ready to go. So the only possible future enhancements to the BMC would be the leak detection that was mentioned earlier, and some people have spoken about there may be flow rate or valve control at the BMC level, and I don't know if that physically exists, but if it does, from a hardware management perspective, we can deal with that. We'll have the schema and attributes. Hey John, how you going?
So sorry for attending late. I was told that I wasn't even presenting. He was presenting.
No, I just made a comment.
I guess I'm just here to answer questions. So to answer your specific question, if you grab a BMC implementation of OpenBMC, it will support Redfish. It just won't have the models. So.
Will this include the models for that?
Right. So yes. This is how the process goes. Is that Redfish is owned by DMTF. They will extend the models. OCP will prescribe a specific resources. So if they say, hey, you gotta have this cooling resource, then they can mandate it through a OCP profile. That OCP profile is in JSON. It's machine readable. It can be read by a test that the DM has written, which actually reads the profile, auto-generates the test, and tests the conformant implementation. So whatever OCP requires needs to be implemented. We can test at the backside when a product gets proffered up that says, we support this profile. So that's why the focus here is on Mick helping Redfish extend the model into cooling, because the DMTF knows nothing about cooling. They know about servers, no, nothing about cooling. So the benefit of having him in the task force was very good. Once the model has been extended, OCP needs to make a prescriptive requirement by writing a profile, which I believe is the follow-on activity that he has, is out of this big additional model, which ones are required, which ones are optional, and that should be the next product out of his work group.
Yeah. So, I mean, from out of that example that I showed, the CDU is the gap that we're working on, and the CDU is included in the white paper that was just published. So again, not to reiterate again, but we want people to go in, look at what we said is needed to manage and model a CDU, give feedback.
So one of the things we have discussed is with all this telemetry and control, where do you put the policy? So you have automated policies that you want as far as if I sense a leak, this is what I want the cooling unit to do. Redfish actually has a model for policies, which is currently a work in progress that you can also find and make comments. But it will basically map a set of sensor or metric inputs to a set of policies that you want acted upon trigger of a sensor.
Yeah, and that's a good example. What was mentioned earlier about the server level leak detection, like what happens at the rack or system level, and that's what John was talking about. The policy would control, pardon the pun, what happens at the CDU or at the system level, because it will say, hey, this server's leaking, do I shut down the whole CDU? If I can, do I shut down the manifold valve? So that's what we're into. Hey.
I don't think the mic's, oh, there it is. So, so fan control in servers has obviously been well understood for a long time, and the benefits of, reducing system power by controlling fan speeds and all that. And it's pretty straightforward in a server. This is doing a similar kind of thing, what you're talking about, but on a much larger scale involving a lot more moving parts. And I'm just curious, have you done any work to quantify, like, how much money do you save, for example, by controlling a CDU, varying the pump power? And is it similar benefit as to doing fan control in a server, or what? Because this is going to be reasonably complex, I guess, to get all this stuff working. I'm just curious, what's the payoff?
So the question is, with the specific example I gave about the cold plate optimization, like what money is to be saved, by throttling or changing the CDU depending on what the servers are doing. This particular example wasn't about saving money, it was making sure that none of the servers go out of their thermal thresholds and they don't throttle. Now, in terms of saving money, this is an abstract, and we would have to do a lot more work as to what would be involved to save money. But like I said, it's probably not going to save money, because in this particular case, it would be increasing the flow rate. That's all it does, is increases the flow rate through this CDU. So every single server is going to get more flow rate to cool one down. So as far as I know, the infrastructure doesn't exist to switch manifold, have a smart manifold, but maybe it will in the future, and in which case it may save you money, because you can adjust the flow rates to each server to keep it within its range, and you're not overcooling or overpumping. No.
Oh, I really like the idea of adding the sensors on the cold plate, and I think it not only give you insights on how you can control the cold plate, the liquid, to increase its power of cooling, but also give you insight between the junction temperature and also the cold plate to know the temperature drop of your interface. So if that degrades, it indicates when you will see a huge difference, and then you know where to service instead of just the liquid.
Yeah, and that's right. And like John was saying, and John's question earlier, what we're doing from a hardware management perspective is we're just making sure we can capture all the sensors, and we can get that information into the hardware management model. So if people want to put sensors in there, we need to know about it so it goes into the redfish model. So we're not prescribing any kind of physical attributes or any kind of requirements on terms of sensors that you require or whatever. There may be sensors in the profile that OCP decides is mandatory for a CDU, for the inlet outlet, for example, but our main job is to make sure if you want to have flow rate sensor in the BMC, then we make sure that redfish can accommodate that, for example.
Okay, thanks.
Okay, I think we've got like, what, 1 minute? Is there any final questions? All right, as with anyone else, I will be around the rest of the day. Might be hard to find me, but I'm sure you'll be able to if you just look up. So, thank you all.
And you'll be at the Cooling Environments lunch, right?
Yes, of course.